and we successfully implemented a Caesar cipher in Python. Hey guys, welcome back to my channel, the best place to build your tech career and have fun along the way. It feels so good to be back in front of the camera and making content for you guys. The reason why I've been gone a little bit is because midterms happened, and then midterms got extended, and then project deadlines got extended, and so I was focusing on getting my priorities straight, finishing my midterms. But today I'm so excited to share with you my first ever coding tutorial. It's going to be an easy, beginner-friendly Python coding tutorial, and I'll be going over a Caesar cipher. So if you've ever wanted to encrypt messages, send secret messages to your friends, and then have them send secret messages back that you can decrypt, that's what we're going to be going over through this video. And I'm super excited because I love using Python. It's my favorite language ever, and I wanted to make this video for anybody, so even if you have zero coding experience at all, you could still run this program and have it work. Or if you're an advanced coder, you could learn something new from this program as well. So I'm so excited to get into this video. I'm going to go over what the Caesar cipher is, and then I will start doing the code with you guys, and I hope you join along. I'll leave some links and resources to help you out if you don't know how to get started with coding. I also have a video on some other resources on where to get started learning how to code in case you're interested. But yeah, I'm super excited, and with that, let's get into the video. So first, I'll quickly explain what the Caesar cipher is. In cryptography, the Caesar cipher, also known as the shift cipher, is one of the simplest and most widely known encryption techniques. It is a type of substitution cipher in which each letter in the plain text is replaced by a letter some fixed number of positions down the alphabet. And the best way to explain this is with an example, and you can reference this image on the right. So for example, if you had a right shift of 3, where that would mean the key value is 3, B would be replaced by E, and C would become F, and so on and so on. So if you start at B, B goes to C, that's one position over, C goes to D, that's the second position over, and then D goes to E, that's 3 positions over, and we can see B goes to E, C would go to F, and then D would go to G, and so on and so forth. This method is named after Julius Caesar, who used it in his private correspondence. So our program will be able to encrypt and decrypt messages. Here's an example of what an encrypted message would look like. So we would start out with our message, which would be hello world, and if our key value is 3, these are how the letters would shift. H would go to K, E to H, and so on and so forth. And our resulting encrypted message would be KHOORZRUOG. And then for the decryption, if we took that crazy message and we're like, oh no, what did the original message look like? I'm not sure. We would input the key value, which is 3, and then we would be able to decrypt that message successfully. And that would mean K would be switched to H would become E, O would become L. And once we substituted all of those characters, we would get our decrypted message, hello world. So before we dive into coding, it's always good to have an outline of what your program will need to do. So here's an outline of the Caesar cipher program we will be making. So first, we need to decide if we are encrypting or decrypting, and we will ask the user. So we'll need user input. We will also need the message that we will be performing our operations on, which will also come from user input. And then we need the key value, which is the shift from user input. And then we will need to write code to perform encryption. We will also need to write code to perform decryption. And then lastly, we will need to print the encrypted or decrypted message. All right, so now that we've gone over the logic behind a Caesar cipher and we understand how it works, we are ready to start coding. So if you're completely new to programming and you don't know where to type and run your code, I've left this link here for you. So you can go to this website, type your code just as I'm typing my code, and you'll be able to run it and see it working. And if you're a more advanced programmer, you probably have your IDE of choice. Maybe it's PyCharm. I'm using IntelliJ. here. So I just have a caesarcipher.py file made, and I am ready to start coding. So we will be encrypting or decrypting messages which are from the user. So we need to take user input. So how we're going to do this is we're going to prompt the user to type in a message. So we can store this as a variable called user input, and it will be user input equals input and then a prompt. So in our case, we can say, do you want to encrypt or decrypt a message? And then type E for encrypt or D for decrypt. And just in case the user types lowercase e or d, we can convert user input to the uppercase version, which is just the method user input.upper. So now we will write two separate things for encrypt and decrypt. So for encrypting a message, that will apply if user input is equal to E. So that means the user has specified that they want to encrypt a message. Notice here that we are using the double equal sign, which is the equivalence operator. So we are checking to see if user input is equivalent to the character capital E. If we were just using one equal sign, that would be the assignment operator, and that would not check equivalence. So that's why we're using the double equal sign. So now we will prompt the user to enter the message that they want to be encrypted. So we can call the variable string to encrypt. And again, this is another input. And we can prompt them by saying, please enter your message to encrypt. We also need user input for the key value. And the key value will determine the shift of the message. So for example, if the message is uppercase C and the key value is 3, then that means C will shift 3 characters over. So it goes to D, then E, then F. So that means C would be encrypted to F. And so we'll store this as a variable. Key equals input. Please enter a value between 1 and 25. Notice we can't say between 1 and 26 because if the key was 26, it would just bring us back to the original character. Now we need a variable to store the encrypted string, so we can call this string encrypted. And right now it'll just be an empty string. Now we're going to use a for loop to go through each character in the string to encrypt variable. So this for loop will make sure we get to each part of that string, so each individual letter that the user will type. So it will go for character in string to encrypt. So here's where it's going to get interesting. I'm going to cover the cases of if the character is in uppercase or a lowercase character. I'm not going to go over punctuation in this version, but if you want to challenge yourself and let me know how you would encrypt the punctuation later, please feel free to do that. But right now we're going to start with if the character is an uppercase character. So we'll do if character dot is upper. And so now we get into the crazy cool formula. So first I'm going to type the whole thing and then I will break it down into parts. So if the character is an uppercase character, string encrypted equals string encrypted plus CHR and then in parentheses ORD character and then plus key minus 65, and then out of those parentheses, mod 26 plus 65. So now let's dissect this part just a little bit. I'm going to comment out our code thus far. Okay, so to break down this big formula, we will put this up here for reference. And first, I'm going to talk about the ORD function. So this method converts a character into its numeric ASCII value. So if you had the character, so if you used ORD on the character capital C, it would give you the value that C is on the ASCII table. And I'll put a picture of the ASCII table for reference in case you've never seen it before, but each character corresponds to a numeric value. And then the CHR method does the opposite. So if you did CHR of 67, it should give us capital C, which it does. So now we can go a little bit further. So 65, why is 65 important? We're focusing on the uppercase values in the first part of our if statement. So in our case, if character is upper, on the ASCII table, the uppercase characters are from numbers 65 through 90. So that's why 65 is used. So now we can look at this big equation in a smaller example. So let's say our character is capital C and our key value K is 3. Step 1 would be ORD of char plus K minus 65, and then we can print step 1 to see what's going on. So we can see our character capital C has now, from step 1, has produced 5. Step 2 is to modulo 26, the previous step. So it's step 1 modulo 26, and that's because there are 26 characters in the alphabet. So we can print step 2 and see what's happening there and run the code. And then we can do step 3, which equals step 2 plus 65, and see what character that is. So now we are at the value of 70. And the last step, step 4, is to CHR that value. So step 4 equals step 3. Actually, it equals CHR, step 3. And then we can print step 4 and see what is happening. Okay, this is a good sign. So these were each step, and this kind of shows you how we can get from C to F. And that makes sense because when I explained before, if the key is 3, that means you shift C over to the right 3 places. So it goes to D to E to F. So we wanted the value of F, and that's what we ended up with here. So now that we understand that, we can delete that and go back to our beautiful code. And I'm just going to be uncommenting where we were at. So the reason why this is being added to the string encrypted is because originally string encrypted is an empty string with nothing in it. And then when we start the for loop, we look at the first character of the message, which is string to encrypt. And so we go through that first character, and when we first start, there's nothing in the string. And so this will just be added to that empty string. And so the string will have one character, and then it'll go to the second character. And then when we go through that, it will perform this function on the second character of the string. But then we also need to keep track of the previous character, which is stored in string encrypted. So at the very end, string encrypted will have the full encrypted message. So now we need to consider the case if the character is lowercase. So we'll do elif character dot is lower. Now we can note that the ASCII values for lowercase letters range from 97 to 122. So we can copy and paste what we have from is upper, but then we will change the 65 value to be 97. And that will just adjust for the placement of the characters in terms of the ASCII table. And then lastly, since this particular code will not affect punctuation, I want the punctuation to remain intact. We'll just do else. So this means that if the character is upper, it will go here. If it's lower, it will go here. If it's not upper or lower, it will go to this else statement. String encrypted equals string encrypted plus character. And now we can get out of the for loop. So something I forgot to do earlier, just in case, is to typecast. So we're going to typecast the key to be an integer. And up there, we'll just do key equals int key. This just makes this equation easier to compute. And so we have to ensure that this value is an integer. And so down here, we will convert the key back to a string so that we can print it in a better manner for the user. And so we'll print you use the key value of plus key. And then we can also print your encrypted message reads. And then we will print encrypted message, which would be string encrypted. So this is a good point to try to run the code. Perfect. So we got prompted, do you want to encrypt or decrypt a message? So I will type E to encrypt, and I can say, okay, let's see. Hi, I'm Liz. And then that would be my message. So now I can choose, let's say, 3 as my key value. And this is what my cipher would look like. So if we kind of mentally do this, 3 characters past H, so H, I, J, K, that matches with K. And then I, J, K, L, that matches with L. And also it's case sensitive, so the H is capitalized, the K is capitalized, and then we have the I, and then the L, and then Liz, and then the O. So that's a good sign that we're on the right track. Now I missed a colon here, so I'm going to put a colon because that's going to bug me. Perfect, okay. So now we get to do the decrypting part, and since we've already gone through the trouble of the encrypting part, this will be a lot easier. So up here we said that we would decrypt if the user entered a D. So we will check if user input equal capital D. And then we need to prompt the user for the string to decrypt. So I'm just calling this, the variable will be string to decrypt equals input. Please enter a message to decrypt. And then we have to prompt them to enter a key. So it will be key equals input. Please enter a value between 1 and 25. You guys can just copy and paste that from earlier. And then again, we will convert the key to an integer so that it doesn't interfere with the math later on. And then we will call the string decrypted. And so this will start as an empty string. So for character in string to decrypt, now we have to do the uppercase and lowercase scenarios. So if character dot is upper, and I'm going to copy and paste the code for is upper, and then I will just change a few things, a few key things. So this will be string decrypted. And then instead of adding the key, since this is decryption, we will subtract the key. So we're not going from C to F, we're going from F to C. So that's why that is changed there. And then I can also copy and paste we'll just copy and paste the rest of the else and the else if statement. And then we have to adjust the indentation, otherwise Python will get angry at you. So again, we have to change this to string decrypted. I love copy and paste. It just makes things so much faster. And then again, you have to subtract the key, not add the key. And then lastly, we can just copy and paste what we did over here. And make sure this is all out of the for loop. So if these statements were indented, that means they're still in the for loop, and we don't want that. So we keep them outside the for loop. And then we will change this to decrypted message, and then print string decrypted. And then the last thing that I put in this code, right now we have an if and an if, but what if the user doesn't type an E or a D? So we can just say else print end of Caesar cipher. You could also do print invalid input, try again, but this just keeps it simple for now. So we can try out the decrypting. So we'll start with an encrypt and then we'll test it against itself. So we can encrypt and we'll do, hi, I'm Liz. We'll use the key value of 3. And then I'm going to copy this message. And then I'm going to run again. And I will choose to decrypt. This is my message I want to decrypt. Boom. My decrypted message reads, hi, I'm Liz. So that means we did it correctly and we successfully implemented a Caesar cipher in Python. So I'd love to know how you guys did with this Python coding tutorial, if you were able to implement the Caesar cipher and try some different test strings and sentences with it. And also let me know if you like this style of video, if you feel like I was going at it too fast of a pace, too slow of a pace, or if you have other ideas of projects you'd like me to code. I kind of just picked one from the list that I made last week on beginner-friendly programming project ideas, and I'm also in a cybersecurity course this semester, so I was excited to implement something that's cybersecurity related with encrypting and decrypting messages, and I'm so happy that I could share that on my channel. If you're new here, I do upload on Tuesdays and Fridays, and I upload details of my makeup looks on my Instagram, Liz_Victoria_YT. I occasionally upload on my TikTok, which is the same username, Liz_Victoria_YT, and I'm just so excited to meet more of you. Please don't be shy and please comment in the comment section because that makes me so happy, and I also love integrating your ideas onto my channel. With that, I hope you have a wonderful weekend ahead of you, and I will see you on Tuesday.